Level 1. You're holding the detonator. It's smaller than you imagined. It fits in the palm of your hand. Looks like a cheap remote control, the kind you'd use to change channels on a lazy afternoon. But what's connected to it is not a TV. It's 1.5 tons of C4 plastic explosive distributed across 47 strategic points of a 28-story building. You're a controlled demolition engineer. That's what it says on your badge. That's what you explain when someone asks what you do for a living at Christmas dinner. The building is 92 meters tall. It took 4 years to build. In 11 seconds, it will cease to exist. You press the button. The building sways for a second. It looks like it might escape. Then it gives in. The concrete turns to cloud. 28 floors collapse into themselves like an accordion. In 11 seconds, 47,000 tons of structure become 15 meters of rubble and dust. Energy released approximately 50 gigajoules, the equivalent of 12 tons of TNT. That's a lot. For controlled demolition, that's a lot. But in the grand scheme of things, it's a whisper. Level 2, the conventional bomb. You leave the threshold of engineering work and enter the threshold of instrument of war. A GBU-43B bomb. The Americans nicknamed it Moab, mother of all bombs. The largest non-nuclear bomb in the United States conventional arsenal. It weighs 9,179 kg. It's dropped from a cargo plane. Not a fighter jet, a Hercules. It rolls out the rear ramp like ordinary cargo and parachutes down before detonating 1 meter above the ground. The blast has a total destruction radius of 150 meters. The damage radius extends to 1.6 kilometers. The detonation can be heard 32 kilometers away. In 2017, the Americans used one of these in Afghanistan against underground ISIS tunnels. The Afghan government confirmed 94 dead, no survivors in the impact zone. Energy released, 46 tons of TNT. You're scaling up. But you're still at the level of humans killing humans with human tools. The next level no longer has that innocence. Level 3, the Hiroshima bomb. August 6, 1945, 8:15 in the morning. Hiroshima, Japan. A city of 340,000 people starting another day of war. The B-29 bomber, Enola Gay, flies at 9,400 meters altitude. It drops a single device, nickname, Little Boy, the most disturbingly innocent name for the deadliest object that had ever existed up to that moment. Little Boy detonates at 580 meters altitude. The height was calculated to maximize the area of destruction. The temperature at the epicenter reaches 3,000 to 4,000 degrees Celsius in tenths of a second. For reference, iron melts at 1,538 degrees. What's at the epicenter doesn't melt, it evaporates. Energy released, 15 kilotons, 15,000 tons of TNT. 70,000 people die instantly. Another 70,000 die in the following weeks from burns, radiation, and organ failure. 1.6 kilometer radius. Near total destruction. But Little Boy was a first-generation bomb. Inefficient. Only 1.7% of the uranium-235 it carried actually fissioned before the explosion dispersed the material. The rest was waste. The scientists learned from that and built something far worse. Level 4, the hydrogen bomb. You've heard of megatons. It's time to understand what that means. 1 megaton. 1,000 tons of TNT. Hiroshima was 0.015 megatons. The first American hydrogen bomb tested in 1952, codenamed Ivy Mike, released 10.4 megatons, 693 times more powerful than Hiroshima. The coral island of Elugelab in Eniwetok Atoll simply ceased to exist. Where there had been solid ground, there was now a crater, 1.9 kilometers in diameter and 50 meters deep, submerged in the Pacific Ocean. But Ivy Mike was primitive. The Soviets had another plan. Here I ask you a question. The Soviets had the capability to build a bomb 3,300 times more powerful than Hiroshima. The very scientists who designed it refused to build it at the original size because they said it was too large for any rational military use. It would be nothing but terror on a geological scale. They built it anyway, but at half the planned yield. Would you have built it at full size? Tell me in the comments. But it doesn't matter what you would have done, because in October 1961, the Soviets detonated the Tsar Bomba, 57 megatons, the largest explosion ever created by human beings in recorded history. The nuclear mushroom cloud reached 67 kilometers in height, 3 times the cruising altitude of commercial aircraft. The heat wave could cause third-degree burns at 100 kilometers from the epicenter. The plane that dropped it barely escaped. Even flying at 270 km/h in a straight line, the shockwave hit it and threw it 1,000 meters downward before the pilot regained control. Energy released, 57 megatons, 3,800 times Hiroshima, but it's still a human creation, still something you could fit in a room. Load onto a truck. The universe does not operate at this scale. Level 5, the impact that killed the dinosaurs. 66 million years ago, an asteroid 10 to 15 kilometers in diameter crosses the Gulf of Mexico at 20 kilometers per second. There is no sound before the impact. In the vacuum, It traveled in absolute silence for 4.5 billion kilometers until it found Earth. The impact lasts less than a second. Energy released 100 teratons of TNT. For comparison, the Tsar Bomba had 57 megatons. 1 teraton equals 1,000,000 megatons. This impact released 100 of those. It is 1.75 billion times more energetic than Hiroshima. The rock and steam from the impact were ejected so fast they left Earth's atmosphere, rose into space, and rained back down on the entire planet like projectiles, heating the upper atmosphere to oven-like temperatures for hours. Everything in the open air died from the heat before the nuclear haze even had time to block the sun. 75% of all species on Earth, extinct. In one afternoon, that the universe barely noticed. Level 6, a supernova. You know the sun. It's 1.4 million kilometers in diameter. The entire Earth could fit inside it 1.3 million times. In 5 billion years, the sun will expand, swallow Mercury, Venus, probably Earth, and then, without any dramatic explosion, it will simply shrink. Turn into a white dwarf, a cosmic ember the size of the Earth with no light of its own, cooling for trillions of years. That is the quiet death of an ordinary star. But larger stars don't have that gentleness. A star with more than 8 solar masses dies differently. It collapses. The core, as dense as a solid block of neutrons, abruptly stops collapsing. The rest of the star, hundreds of billions of tons of plasma, keeps falling. And then it bounces off the core like a concrete wall. The resulting shockwave explodes outward. A supernova releases in tenths of a second more energy than the sun will release over 10 billion years of life. Total energy, on the order of 1044 joules. For perspective, the Tsar Bomba released 2.4 x 1017 joules. A supernova releases 10 to the power of 44. That's 27 orders of magnitude of difference. It's like comparing a grain of sand to the planet Jupiter. A nearby supernova, say 25 light-years from Earth, would sterilize the entire planet. Ionizing radiation would destroy the ozone layer within days. The surface of the planet would be exposed to lethal UV levels for decades. Total extinction of virtually all macroscopic life. But it's still just a dying star. Still common? It happens in our galaxy once or twice per century. Level 7, Galactic Collision. The Milky Way is 100,000 light-years in diameter. It contains between 100 and 400 billion stars. And it is on a collision course with the Andromeda Galaxy. This is not theory. It's confirmed. In approximately 4.5 billion years, the two galaxies will collide. You'd imagine it as a brutal crash, 2 disks of stars shattering in cascading explosions. But that's not how it works. The stars are so spread out that the probability of any individual star colliding with another is nearly zero. The two galaxies will pass through each other like two ghosts crossing paths. What changes is gravity. The orbits of trillions of stars are rearranged. Solar systems are ejected into intergalactic space. Others are hurled close to the supermassive black hole at the center. The solar system itself may be completely ejected from the newly formed galaxy. The energy involved has no adequate name in human language. It is simply the gravitational reorganization of two systems, each containing hundreds of billions of stars. But the universe is still far from over. Level 8, the supermassive black hole. At the center of the Milky Way sits Sagittarius A, a supermassive black hole with 4 million solar masses. At the centers of larger galaxies, these objects reach billions of solar masses. The black hole at the center of galaxy M87, photographed in 2019 by the Event Horizon Telescope Initiative, has 6.5 billion solar masses. The event horizon of the point of no return has a radius of 19 billion kilometers. Uranus is 2.8 billion kilometers from the Sun. This black hole has swallowed a space 6 times the orbit of Uranus as its minimum radius. When matter falls toward an active supermassive black hole, it forms an accretion disk. It heats to billions of degrees. It emits relativistic plasma jets, streams of matter traveling at a significant fraction of the speed of light, that can extend thousands of light years in length. Those jets can sterilize an entire galaxy. Not a planet, not a solar system. An entire galaxy of 100 billion stars and their planets. But even so, it's still just one object in a universe of 2 trillion galaxies. Level 9, the Big Rip. The universe is 13.8 billion years old. It is expanding. Not just expanding, the expansion is accelerating. The force behind this is called dark energy. It accounts for approximately 68% of the total content of the universe, and we still don't know what it is. One theory for the end of the universe is called the Big Rip. If dark energy continues accelerating the expansion without limit, at some point the expansion of space begins to overcome the forces that hold structures together. First, galaxy clusters dissolve, galaxies come apart. Then, solar systems. The sun drifts away from Earth because the space between them expands faster than gravity can hold. Then, planets. Earth's gravity can no longer hold the planet together. The Earth fragments. Then stars, fragmented. Then, atoms. The space between the nucleus and electrons begins to expand. Atoms rupture. Then, atomic nuclei. Then, protons and neutrons. Then, quarks. At an estimated time between tens of billions and hundreds of billions of years from now, the last thing to exist will be low-energy radiation traveling through an infinitely expanding space. No galaxies, no stars, no planets, no atoms, no structure, just space expanding forever. Level 10, the Big Bang in reverse. But there is an even more extreme theory, the Big Crunch. If gravity eventually overcomes dark energy, and some models allow for this, the universe stops expanding, begins to contract, slowly at first. Then faster. Galaxies draw closer. The cosmic microwave background, the echo of the Big Bang, begins to heat up. Stars merge. The space between galaxies disappears. The entire universe collapses into itself. In its final moments, all the matter and energy of 2 trillion galaxies, of 300 sextillion stars, of everything that ever existed across 13.8 billion years of cosmic history, is compressed into a point smaller than a proton. The temperature reaches the Planck limit, 1.416 x 1032 Kelvin. The maximum heat that physics as we know it can describe. Space and time cease to exist as separate categories. There is no before, there is no after, there is no here, there is no there. And then, maybe the cycle begins again. A new Big Bang, a new universe, new laws of physics, new galaxies, new stars, new planets. Maybe in one of them there is someone exactly like you, watching exactly this video, thinking exactly this thought. Or maybe not. Maybe the final collapse is simply the end. A point dense, hot, silent, with no memory of what came before, with no one left to remember. You started today holding a detonator for a 28-story building, thinking you had power over something. In the end, you are made of atoms that have existed for 13.8 billion years, temporarily organized in the form of a conscious being, on a planet orbiting a mediocre star, in one galaxy among 2 trillion others, in a universe that will end in a way we won't even be able to describe. Because we won't exist to see it. The greatest destruction of all has no explosion. No mushroom cloud. No shockwave. No radiation. It's just space silently expanding until nothing can hold together anymore. And then the silence. The same silence that existed before.